Welcome to my kcse revision channel. Marita James. Kindly subscribe, click the notification bell. You get notified once I upload a new video. Today we are looking at kcse revision chemistry form 1 work, and our topic is a simple classification of substances. Then we have the separation of colored substances. I'm going to take you through the analysis on how the questions are set using the paper chromatography from this topic. We are starting by this question. The diagram below shows a paper chromatogram of substances A, P, and C, which are colored. So, the origin where the solvent starts from is called the baseline. So this one here, this is the origin. So if you will be asked sometime, you name the baseline and the solvent front. The baseline is normally the origin, and the farthest distance where solvent can move is the solvent front. Now indicate the solvent front and the baseline on the chromatogram. You can see the farthest distance where substance moves is the solvent front. So we can have a solvent front via there. And then we have a baseline, which is of course the origin. Which substance is pure? So the substance which is pure, we have pure substance separates into one spot, and impure substance separates more than one spot. So we can have pure substance, this one here, it separates into one spot. This one separates into one spot. Then we have the impure substance. Impure substance separates into more than one. So impure substance separates more than one spot. It separates more than one spot. Now, from our question, which substance is pure, you need to explain. You can look at P because it has separates only into one spot. So this is a P because it is separates into one spot. So if you will be asked also to give the impure substance separates as more than one spot. Then we have substance D is a mixture of P and C. Indicate this chromatogram in the diagram. So we have substance D is a mixture of P and C. So we can have is a mixture of P and C. Indicate it is chromatogram in the diagram. So you can see this one has been indicated. So we have this is P. You can indicate it like that. This it has been indicated there. And then we have A, which is of course separates into that. We have A, so that you can indicate this chromatogram on the diagram. So this one here you indicate P, and of course then you can indicate A. Suggest two reasons why separation occurs in this method. Why do we have separation occurs in this method? In other words, now you can also be asked what conditions are required to separate the chromatograms present in the dye. Suggest two reasons why. This one is asking you to know the conditions required to separate the dye. So we can have difference in solubility in a solvent. You can also have difference in adsorptibility over the adsorbent medium. So we have a difference in solubility of a solvent, and then we have a difference in adsorptibility over the adsorbent medium. This is the different solubility of a substance in a solvent. You can also say that the difference in solubility of a substance in a solvent, or you can say that different adsorptibility of a substance over the adsorbent material. So this question can also be framed as the conditions required to separate the chromatograms present in the dye. right for applications of chromatography, a very important part. So the application of chromatography is used in separation of dyes. So we have used in the separation of dyes. Again, it is used in analyzing dyes in food coloring. So it can be used in analyzing dyes in food coloring. It can also be applied in food industry to identify contaminants in food and drinks. This one can be used to identify whether there is the food has been contaminated with poisons. So in industry, it can be used to identify contaminants in foods and drinks. It can also be used in food in sports to identify the banned substances like the steroids. So it can be used by it can be applied in the it can be applied in a in a it can be applied in sports, whereby it can be used to identify the illegal drugs in the plant. It can also be used in pharmacy and medicine to test the purity of the drugs. So those are some of the uh, applications of chromatography. So in sports here, chromatography is used to identify banned substances. For example, steroids in urine or in plant. So you can have these steroids in urine. You can have this one in urine, or it can be used to identify this one in a plant. We can also have this one is used in pharmacy. In pharmacy, the pharmacy in pharmaceutical industry to test the purity of the drugs. In the food industry to identify contaminants in the foods and drinks. So it can also in industry, it can be used in cosmetic industry to identify harmful substances. We proceed. Study the diagram below and use it to answer the question that follows. Now we use this diagram. Name, okay, before that one, we can have, as I said in our first question, that we have the origin where a substance, where a solvent starts from, and we have the fastest distance covered by the solvent. So that one is called the solvent front, and then we have the baseline. Name the technique used to separate the dye. So the technique used to separate the dye, this one is called the ascending paper chromatography. So this technique is called ascending paper chromatography. Very, very important to note. Which letter represent a baseline? Of course, a baseline is represented by letter N, which is the origin, and the solvent part, which is the solvent front. It is the farthest distance covered by the solvent, which is represented by letter M. Which chromatograms are present in the die E? So the chromatogram which are present in the die E, you look at those chromatograms which moves the same distance as E. For instance, here you can identify A. A has moved the same distance. So A has moved the same distance as, so we have this is a spot A, and then we have this one is die E. So they have moved the same distance. So we identify that one as A. And again, you can look at C. C has also moved the same distance as die E. So we have that one as A and C. Which dye is insoluble? Insoluble dye, it moves zero distance from the origin. So that substance which moves the zero distance from the origin is insoluble substance. Now, and in this case now, we can have this P. P has not moved any distance, so it has moved zero distance, so that one is insoluble. Soluble substances, we can see that it moved the farthest distance, it covered the farthest distance from the origin. The one which moves zero distance from the origin is insoluble. The one which moves farthest distance from the origin, for example, you can have A here, it is soluble. Which dye is impure? Impure substance separates more than one spot. The pure substance separates more than the pure substance separates only one spot. As I said in the first case, pure substance separates into one spot, impure substance separates more than one spot. So the substance which separates into more than one spot is E. And they explain your answer, it has more than one spot. Very, very important to note. Which chromatogram is most soluble? The most soluble chromatogram moves the farthest distance from the origin. And in this case, we can have this A, which covers the longest distance, and therefore this one is most soluble. What conditions are required to separate the chromatograms present in the dye? So the conditions is different solubility of a substance in the solvent. Then we have different adsorptibility of a substance over the adsorbent material. We proceed. Now, spots of a pure pigment, P and Q, and a mixture M. So we have pigments is P and Q, and a mixture M were placed on a filter paper and allowed to dry. The paper was then dipped in a solvent. The result obtained were as paper chromatogram. So this is the result that you can obtain from here. Which is the baseline? The baseline is the origin. So this one is indicated here. The baseline is the origin. And the solvent front, it is the farthest distance where solvent can move. So it is indicated at the far end there. Circle the substances M is made of. M is made up of what substance? So circle the substances which is M is made of. So it has been circled, it has been made of this one. So you can circle this. You can also circle this one here. And you can circle this one here. So M separates out into 3 spots. So the substances, so you can have the first one, second, and then we have the third. So these are the substances which M is made of. Which of the pure pigment was a component of M? We need now to have the pure pigment. A pure pigment, we said that which of the pure pigments was component of M? To identify the component of M, it is the one which moves the same distance as M. And in this case, if you can look at this one, then we have this one here. So P has moved the same distance as M. So that one is P. It has moved the same distance with spot M. But when you look at Q has not moved the same distance because it is not matching any of the spots of M. Name a solvent that is used in paper chromatography. In paper chromatography, we have a substance which can be used there. We use propanol, or you can use ethanol, or you can also use methanol. Very, very important to note. So the solvent which is used in paper chromatography, we have propanol, you can have ethanol, and then you can also use methanol. Water is not used. Why is water not a suitable solvent in a paper chromatography? Simply, we have water does not dissolve any organic compound. Water does not dissolve an organic compound, and that is the reason why water cannot be used as a paper chromatograph. So the only solvent we have is a propanol or ethanol, or you can use methanol, but water is not used because it does not dissolve organic compounds. Now look at this, another question here, that this is a green coloring material was placed at the center of a circular piece of paper. So we have a green coloring material which was placed on a circular piece of paper, and then it was allowed to dry. Drops of a solvent were added to the center of the filter paper and eventually 2 circles were produced as shown. So you can see when drops of a solvent were placed here, there were 2 circles that were produced. So we have the first circle and then we have the second circle. So we have the 2 circles were produced as you can see on this diagram. Now, describe a process by which a dilute extract could have been made more concentrated. This one is just placing it in the sun to evaporate the solvent. So placing in the sun to evaporate the solvent. That is the process in which you will make the extract more concentrated. So you put it on the sun to evaporate the solvent. Name a suitable piece of apparatus for adding drops of the solvent to the center of at the controlled rate. In this case here, you just use a dropper, simple. What is the name of the process by which the circles were produced? The name of the circles, the process by which the circles were produced is just paper chromatography, simple as that. So we have this one as paper chromatography. What information does this experiment provide about the coloring matter in grass? In the grass now, about the coloring matter in grass, because if you put a solvent here, it separates out, it produces 2 circles. The produced 2 circles means it consists of 2 colors because there is a production of these two circles. So there consists of 2 colors. Name a suitable solvent for the experiment. So you use propanol or ethanol, or you can use methanol. Remember, as I said earlier, water is not used because water does not dissolve organic compounds. Explain why water is not used to extract the green matter. Explain why water is not used to extract green matter. Green coloring contain organic compounds, and therefore if it contains organic compounds, water does not dissolve organic compounds. Water does not dissolve organic compounds. And we have come to the end of analysis on how the questions are set using on the separation of colors. Kindly subscribe my channel, click the notification bell, you get notified once I upload a new video.